So we're going to continue to look at logarithms today, and we're going to formally introduce the idea of a common logarithm. If you have log base 10 of x, it's typically written as just log x. So if you don't see a base written after your log, it's assumed to be base 10. So that log button you have on your calculator is log base 10. So if we wanted to type something like this into our calculator, we'd hit that log button on the left-hand side of your screen, and then just go ahead and type in 6 in parentheses. So on your screen it should say log 6. When you type that in, you should get this. So go ahead and type in the next one here on the right, log of 0.35, and when we go to 4 decimal points, we should get this. Typically, these we're going to be rounding to about 4 decimal points, so just be aware of that. So with that in mind, let's go ahead and solve these. We have an exponential equation, 5 to some power to give you 62. Now, one way to do this is to apply a normal log to each side. So apply our common log to each side. Now on the left side, we have an exponent after a logarithm. Well, one of our properties of logarithms says we could take that exponent and put it in front of the log. But now we have x multiplied by something. So to get x totally by itself, all we'd have to do is divide both sides by the log of 5. And on all these problems, you'll be looking for your calculator-ready form in addition to your decimal approximation. Calculator-ready form is when your variable is already solved and worked out all by itself on one side before you even touch your calculator. So don't touch your calculator till you get your variable on one side all by itself. Then type it in just as you see it to get your approximation. If you have an older calculator, you'll have to put the top in parentheses, then hit divide, put the bottom in parentheses. If you have a newer calculator, you can go alpha y equals, make it a fraction, type in the top, arrow down, type in the bottom, and you should get this. When you get to your tests, you will have to write down 2 types of answers on these types of problems. The calculator-ready form, which will be for most of your points, and then you'll have to do your decimal approximation. So looking at this one here, our variables in the exponent, so we're going to use logs. So I'll apply a common log to both sides. Now we have a variable after a log, so we're going to get that variable down in front using our clog property, which allows us to be able to take an exponent after a log and put it down in front. We now have x multiplied by something, because log of 3 is a nice messy number. So all we have to do to get x totally by itself is get rid of timesing by log of 3. So we'll divide both sides by log of 3. Since x is on one side by itself and we've not touched our calculator, this is our calculator-ready form. We type it in and we get this as an approximation. So we're going to go ahead and try to solve these. So we'll do the top right one here first. We have variables and exponents on both sides. So I'm going to go ahead and apply a logarithm to both sides. A common log, because what I'm doing to one side, I got to do to the other side. So I'm applying a common log to both sides. Well, now in each case, I have an exponent after a logarithm. So I can put that exponent in front of the logarithm. Over here, I have an exponent after a logarithm, so I can put that whole exponent in front of my logarithm. Notice, because I have 2 terms here that were part of my exponent, I have to put that in parentheses. So now I'm going to go ahead and take log of 10, which is a number, and just distribute it into my parentheses. Log of 10 times my x, log of 10 times my 2. Now, as a side note, to solve a problem like this, if I gave you 3x less than 1x minus 2, wouldn't you want to get the x's on the same side by subtracting an x from both sides? And then once you got it down to x times by a number, then all you'd have to do is just do some dividing. We want to follow that same idea here. We want to get the x's on the same side. So I'm going to take my x log 10 and subtract x log 10 from both sides. And I would get this. Now, these are not like terms because one of them is an x with a log 5 and the other is an x with a log 10. We know if we could write it as something times x, we could easily go ahead and solve it. Well, here, x is your common factor, so we're going to factor out an x. And then in parentheses, we can leave what would be left if we pull out our x. We don't take out our x, we pull out our x. Because if we take out our x, our current significant other is going to be mad at us for taking out our x. So now to finish getting x by itself, all we have to do is we have x times something. All we have to do is just divide both sides by the parentheses. Now, because we're dealing with an inequality, you'd want to check, is this right here positive or negative? So you'd want to type that into your calculator to see if it's positive or negative. We do that because we're dealing with an inequality. If this boxing green thing was negative, remember you'd have to switch your inequality sign. But in this case, when you type in this green thing, it ends up being positive, so we don't switch our inequality sign. So we have our calculator ready form, and then we could type that in to get our decimal approximation. Now, there is a slightly different way you could have done this problem. You could have realized, oh, on the right up here, I have a common log, which is log base 10 of 10. You could have realized that your log base 10 of 10 cancel, and it's just an x minus 2. Then you could have went ahead and subtracted an x from both sides, factored an x out, and then went ahead and divided. And that would also be acceptable for your calculator ready form. Most of the time, your base of 10 is not going to match what you have here, so you're going to have to do a problem very similar to this. So now we'll go back and we'll do the left problem. Or maybe you want to try it and then watch the video. But in either way, we'll apply a log to each side. Now we can take our exponents after our logarithms and put them in front. Our 5x minus 3 is after a log, we can put it in front of our log. Our 7x is after a log, we can put it in front of our log. So now on the right-hand side, we have a log times our parentheses. So we could take this ugly number and distribute it through into our parentheses. If we do that, we're not doing anything to the left side. It would be x log, or 5x log 3 minus our 3 of the log 3's. So now it's similar to what we had right here in purple, where you'd want to get the x's on the same side. I'm going to choose to take this to the other side. So I'm going to subtract a 5x log 3 to both sides. Now I have x as a common factor because I cannot just combine these together because one's an x log 2, the other's an x log 3. If they were the same log with our x, then we could combine them together as like terms, but they're not. But we could factor that x out. Factor our x out and we get this. Now we just have x times by something, so all we'd have to do is divide. However, you want to check, is this positive or negative? Because we're dealing with an inequality. If it's negative, then you're going to switch your inequality sign. If it's positive, you don't have to worry about your inequality sign switching. In this case, when you type that into your calculator to just check, it's negative. So when we divide by this, you then have to switch your inequality sign from a greater than to a less than. And then we get what we had over here divided by our parentheses. This is your calculator ready form, and you go ahead and type that in. One last thing we want to do is we want to look at your change of base formula. Allows you to be able to take any base you're given and rewrite it into a form that you can maybe work with a little bit better. Because your calculator does a great job of working with base 10. It also deals with your natural log base E, which we'll talk about in the next lesson. So typically, if you're given something like this with a base, you're going to rewrite it in this form here, where you're writing it with common logs, log base 10. So basically you go log of the u over log of your base. So here, if we're doing log base 2 of 20, and notice it's log base 2 of 20 is how you'd say that, you would go your common log or log of the 20 divided by the log of your base. And so you type in log 20, close your parenthesis in the log, hit divide, then go log of 2 on your calculator, and then you could type or work it out and get this as your decimal approximation. Similarly over here, we would go log of the 18, normal log, log base 10, over the log of your base, which would be log of 3. Type that in, log 18, close your parenthesis, divide, and log of 3.